Thank you everyone for coming today. So before we demo the product, we wanted to tell you what's the inspiration for developing the product. Mr. Ajay Goel has said before, where we spent a lot of time doing cryptography. And then back then in 2021-22, when we were studying the different aspects of the large language models and how to make it private, we realized that there are a lot of scope even there to improve. And mathematics and the things that we have done in cryptography really helped us to understand the AI models on the underlying complexities and the mathematics of AI model to somewhat more clearly. So one thing that we realized in 2022 is that if the trend of AI development goes like this, it is extremely unsustainable. Only a few set of companies will be able to do AI, and a large part of users and a large part of other companies, they will only be calling APIs released by some other companies. So therefore we thought that we need to develop something and which can run on top of commodity hardwares. Commodity hardwares meaning CPUs. So to drive down the demo and what the work that we have done, let me tell you a very small story, and this is actually very real. One is that suppose a class 7 student studying in CBSE and the medium of instruction is English wants to learn history. So basically he has two different options. One is that he gets a good teacher, and second is that he can go online. Now getting a good teacher, we all know, is extremely difficult proposition. There are many teachers, but getting a good teacher is difficult. Online, there is one more problem. Most of the online courses are one way. That means the professors come in the TV or the computer and they will tell what they want to tell, and then you will take notes and that's it. But learning, as we all know, is continuous and a series of iterative questions and answers over a period of time, the true learning. Now, how do you solve that problem? And for a country like India, the problem is very skewed. So the ratio between teachers and students and the number of students that are there in India are extremely high, or at a very large scale. So therefore, one of the ideas that can be done probably is that we design an AI model. And that AI model teaches only one thing, which is history. And as Professor Kamakoti sir said in his address, that we don't need to learn everything. That small, simple model can only learn the class 7 history, and it can be therefore be deployed on all different kinds of devices, online, offline, and then it can teach the student what he wants to learn. He can learn interactive, non-interactive, ask questions, prepare for exams, so on and so forth. And all of these things can happen. But then this small, simple goal to enable a class 7 student who wishes to learn history in India has a huge technological breakthroughs that needs to be done in order for this thing to happen. And what are those? For example, I carry two phones. One is an iPhone 14 and the other one is a phone that is less than 10,000 rupees, a smartphone. And the sub 10,000 phone is actually India. A lot of people carry phones. They have very limited power. They have very limited CPU, very limited memory. So now if you design a model and then you want to provide it to all the students that are there in India, therefore it has to run on that CPU, number one. There are no GPUs in this world today that is being there in a phone. I mean GPUs like what NVIDIA has created. There are a mix of CPUs, GPUs on phones today, but most of the phones that are out there in India, they are all CPU based phone with very limited memory. Second, as Ore said in his talk, that there are methods like quantizations, there are methods like distillations. But then this topic of allowing a student to learn class 7 history is a very important one. you cannot make a model which predicts out or output something which is wrong, because learning is a serious business. So therefore, your model not only has to be running on a CPU, a low-end CPU, but it also has to run, it has to be full of quality, it has to be accurate. Now, meeting both these objectives and then allowing a particular model to run on a phone is actually a very hard job technically. And this is one of the things that Kompact AI has solved. So one of the core messages is that you take a model, you can take that model and run it on a device, and it is a CPU device. You do not do quantization, you do not do distillation, and it can run at a pace which will produce enough tokens so that the quality is there, and at the same time no loss of correctness is there. So it is always correct. So this is one aspect of it. The second aspect of it is that even if you develop the product and a startup goes out to the market and then they want to make it a GTM out of it, it is difficult because GPUs are inaccessible or they are very low in number, and then it's not available everywhere. So if you now put the application on top of CPUs, then the startup can go at any pace in any cloud data center or even on-prem and deploy the solution. And the third and the most important thing when it comes to IIT Madras is that AI researchers or computer scientists, when they want to build a model, they also want to design newer and newer architectures. So if newer and newer architectures needs to be designed, then it also has to be trained. Now to train, you need GPUs and you need a lot of data. So as Professor Kamakoti said, yeah, the lot of data is there, but you still need GPUs. So Kompact AI solves the problem, and as our esteemed board director Ajay Goel has said, we are now focusing on the inference. Very soon we will provide a framework on Kompact AI to do fine-tuning first and then the full training, and eventually we will also provide privacy on top of the Kompact AI platform.